more in depth with our water pollution here. And so I'm going to start with eutrophication. Remember, eutrophication is where high levels of nutrients, they enter a stream, lake, river, and basically they're creating a plethora of algae blooms in here. You can see all the ways around on this diagram that lead to eutrophication, where those nutrients can get into those streams or lakes. Another case study that we have that indicates with eutrophication are the Great Lakes. Great Lakes, again, are the largest freshwater supply that's found in the North America. But one of the biggest areas is with Lake Erie. And so with Lake Erie, which is located, I believe, in this region here, is that the eutrophication or the amount of nutrients that are washed into that particular lake are incredibly high. There's also other concerns, as we've read with the Great Lakes, with the zebra mussels and also with other toxic metals and hazardous waste that has been dumped into these regions. So you can see all the red triangles in this area that are Superfund sites to clean up. Another one that we have right here, we do have laws that regulate this. We're going to address those a little bit later, that do help protect our streams and lakes. And the biggest law right here, of course, is the Clean Water Act that was established in 1972 under the Richard Nixon administration. It was written in the 60s, but later passed under his regulations. And on there, it just regulates what pollutants can go, or regulates the amount of toxins to prevent them from getting into our rivers, lakes, reservoirs, etc. Here's another concern within India with the Ganges River. The Ganges River is a sacred place, but it's also a facility or a lake, or excuse me, a river source where folks will also bathe in there. They will collect water for their consumption as well. Sewage is treated there. Or not treated, but it is dumped into that river as well. But one of the biggest concerns is this is a place where the cremated remains of loved ones in India are actually brought there in a religious ceremony. And so the concern is that the human remains or the ashes are actually floating in there in the river itself. When we look at ocean pollution, one of the biggest concerns, of course, is our coastal regions, where a lot of the waste and debris can actually come up and be deposited off of the shores. Look at this. Half of the world's population lives within an area of water, predominantly the ocean. And look at this. About 35% of the U.S. municipal sewage has been discharged into untreated waters, or it has been untreated and actually dumped into our ocean waters. That is a concern. So that's why our ocean is the biggest place where waste is dumped. The main types of ocean pollutants, these are listed here. Of course, the oil, the petroleum with the Exxon Valdez, and with also more recently the BP spill down in the Gulf. But we also have sewage that is dumped into the ocean, our DDT, and also PCBs being found there, mercury. The point source here would be any of the sewage or oil tankers spills and things like that found. But your non-point, remember, the biggest non-point source is going to be agriculture. You see all these others, but agriculture is probably number one. This also gives you other areas. This diagram showing you the concern with the ocean pollution. One I want to talk about right now is this one right over here, the red tide. Red tide basically is where nitrogen, those nutrients with nitrogen, can cause these microscopic algae to really bloom and grow, and so it kind of mushrooms out. And what happens is, unfortunately, that red tide is very poisonous to most of the fish and marine animals, and therefore it's causing fish kills. And you can see right here on this diagram, that is the red tide out there. It's also called a HAB, which is an acronym for harmful algal blooms. And it creates explosive growths of those algal blooms, and it's derived mainly from sewage that is found or agricultural runoff. Okay, here's another one where the red tide is seen more so. Of course, it has been seen in Florida and off the eastern seaboard, but where the larger amounts of red tide has been located down here off of the Gulf of Mexico. So we're seeing that. We're also seeing the big oil spills again with the tanker accidents. And you can see right in here, this is oil on top on that one. Some of them are intentional, some of them are accidents, and some of them are where the actual oil rigs become disconnected and or is released into the ocean that way. Some of the effects that we have in there, first of all, the volatile organic compounds that are found in our oils actually can cause immediate kill of some of the organisms. If oil is floating on the surface up there, it can coat the bird's feathers, and it can create or cause problems with them insulating themselves or actually being buoyant, floating on there. And then the last one is like heavy oils that can sink down there. It affects our oysters, mussels, and clams, those that are filter feeders. It will actually get clogged in there and create problems there. And of course, we also have oil slicks that can be kind of a film that's found on the beaches. So any other intertidal splash zone species that are found there and exposed during low tide, covered up during high tide, those are going to create problems there. Exxon Valdez occurred in 1989. There was a oil tanker that actually had an accident. I believe the guy was intoxicated. He was released, but he ran his rig up on some of the islands that were in there and caused the tanker to release a lot of oil into the Prince William Sound, killing lots of animals and fish in that particular region. The Dong found its heyday during this time. You can see these otters right here that have their fur coated. Birds, again, have their fur coated as well. Exxon Valdez, because it was in the United States, was very important for us. But when you look at the scheme of things, it was only 53 of some of the worst oil spills that were located out there. Another one is just sewage up in New York, especially New York City. A lot of off of that, they were actually disposed of their sewage actually into the Hudson Bay, into that area. So unfortunately, that region is highly polluted and concerned. The sewage dumping has been restricted. Laws have been reinforced there, so it is no longer a practice. DDT, as we know, has been a pesticide. Rachel Carson did her studies on this one and found the bioaccumulation, biomagnification of the particular component. And one of the biggest things that she noted was that the birds, osprey is one, your pelicans as well, but when they would lay their eggs, the eggs were so thin that it would not support the life of the unborn baby, and so therefore it would die. It wouldn't exist. DDT worldwide has been banned from agricultural use. They are reconsidering it right now with the concern with malaria in the developing countries. PCBs, again, are used in industries, more so like in transformers, to clean them, coat them as they're being created or made. It's also found in your liquid coolants and also in some of your insulations. And what happened is that as the PCBs are located in that wash material, eventually, though, they would release that water and it would go into a water treatment facility or a wastewater treatment facility. But unfortunately, there was nothing there to filter out the PCBs, and that water would eventually end up into the oceans, and there you have problems. And so it can create, again, bioaccumulation in the tissues of the animals. So we're noting that. Minamata Bay, we mentioned that one, where it's mercury, was located in the Minamata Bay area, a neurotoxin as well. And we have right here another case study with the Chesapeake Bay. Chesapeake Bay is the largest estuary. Remember, the Great Lakes are the largest freshwater supply, but your Chesapeake Bay is your largest estuary that's in the United States. Some of the concerns is the water quality in the Bay Area. Also with the seafood industry as well. It has been under remediation, and the Chesapeake Bay has been cleaned up, so it's improving in its water quality conditions. Groundwater pollution is another one. It's more of hazardous waste that can get into our groundwater to contaminate it. One of the things is looking at possibly having the pumping, one solution, pumping groundwater to the surface and then purifying it just to ensure that there is no problems there. And here you can see a diagram showing all the different sources, how those contaminants, where do they come from to get into our water system. And again, if you are burying toxic waste, as you can see right here, eventually, though, those barrels may leak out and it could drain and then get into your water system. Another concern with groundwater is saltwater intrusion, where it travels in. Your well is actually drained out, or you're depleting a lot of the water here. You're getting that cone of depression. And so as the water level decreases, or the sea level right here, a water table, you can see where that sea level or those saltwater intrusions are actually entering into this well. It will later cause some problems. Now let's move on to our water treatment facility. You are going to do 2 web quests to kind of help you understand the principles behind water purification. First thing is our sewage comes in, our gray water from our house, from our toilets, sinks, you name it. And it will be coming in. First of all, they're going to screen it. So if there's any solid materials that have been accidentally flushed down the toilet, those will be filtered out. Then they're going to allow it to settle out, and then that down at the bottom, the solid materials that have settled out, that will be pumped out and go to a reserve tank. You'll see in another diagram. So then this water is then pumped out and pumped into these little channels. And what they do is they add this thing called a flocculant. And flocculants are like these chemicals that basically will mix with those floating substances, and it will attach and it will sink to the bottom. Another thing it likes to do in here during this one, where the flocculant is, the treatment plants, this treatment plants will basically add these microorganisms in there that sort of will feed off of some of the nutrients found in some of the feces or other waste that's located in your wastewater treatment facility. Then when we go over here, that flocculant attaches to those solid particles, pulls them down. We're going to do the same process like over here, and we're going to filter out that water, collect it over here, and then eventually that bottom layer will get filtered out, just like this one will get filtered out, dried out, and then used for other nutrient values for fertilizer. The particulate in here in this collecting bin, there might be just a tad few particles still suspended, but at that point then they will undergo even more filtration process if it's not filtered out. Or what they'll do is then probably add chlorine to it to disinfect it. Now the latest is hitting it with UV light. That's important because it kills any of the bacteria. We typically will store our water in these tall storage tanks. They have those around town. There's one near the old Walmart over there. And basically this is gravity fed. Our storage tanks are gravity fed. They are usually the tallest points in town. Okay. And then the other one, if it's not stored in our storage tanks, it will then go to the public. Again, when we look at our treatment stages, you're going to do a web quest to go more in depth. So these right here are some of the steps involved with screening, aerating it. You're going to check its pH. You're going to add coagulants or flocculants. You're going to take the sedimentation part out. You're going to chlorinate that water. If there's any last filtering, we'll do any more filtering. We'll disinfect and then check the pH just to make sure everything's good. Okay, and here you can see coagulants add, which is like your flocculant. Add it in there, it attaches to that debris, collects it, and goes straight to the bottom. Sedimentation, instead of adding something in there, basically you just wait and let time take its course and let those particles settle. And filtration is sort of like setting up, like in a fish tank, you have filters in there in your water tank. So what we have right here, we were going to create and simulate that filter right there to see how pure the water would be on this one. Final touches, again, disinfectant, chlorine, all of those are byproducts, but some of the concerns with chlorine as a gas is very poisonous, but chlorine also, if pregnant ladies are drinking the water where it's been treated with chlorine, it can cause ulcers in your stomach, cancers, and also miscarriages. Okay, absorption's important. You got to have some kind of filter system in there to activate it. Now, if you would, make sure that you do your water treatment tours that are in there. I have basically a water treatment tour and then a wastewater treatment tour on there. Our sewage treatment, again, when you look at it, 99% of what is going to be treated is probably just pure water, or not pure water, but water on there, a gray water. And so one of the primary treatments in there is to get rid of the grit and try to let it separate out. A part of our wastewater treatment plant, if you live out in the county, you probably are not connected with Greenville Utilities so that your wastewater is not treated. So if I live out in the county, odds are I probably have something called a septic tank. And septic tanks are pretty good, but every now and then, out of a blue moon, you are going to need to have it pumped out. And so they have several companies around town that can do that service for you. Okay? So when we look at this one, our septic tanks, again, they're going to treat your small individual homes, whereas a wastewater treatment plant is going to treat a whole gamut of folks in that arena. Here shows you a diagram of what a home septic system would look like. This is the collecting bin. And then they'll take the water and gravity feed it down. And there's holes in there. It's like a sinker hose. And it will actually release it. So we're not getting the one big clump here. We're getting it at various locations. Here you can see the septic tank system again that was set up with the septic tank here. This is the distribution box, so it will distribute it to the various rods there and allow for the sewage actually to travel to that region. Okay. All right, so here we have again that wastewater treatment plant that we said again. It's just in there settling. Then it moves over here. Again, you could go left or right on there, but you could have the trickling filter on this one, which is where it's like stone pebbles, and as you go down, they typically get a little bit bigger, and it'll help out filter out the water up here. Okay, so what we have down here, you can see the sewage is collected down in here, and the sewage is drying out. They have it visible, so it dries out, and then they will place the remains into the anaerobic anyway on there. Another one that we have is the purifying our sewage by using plants on there as a natural filtering facility there. And to end on this, our drinking water. Our drinking water is very important, and the laws that help us with the drinking water quality is actually the Safe Drinking Water Act. And basically it regulates what goes into water that's being treated. And the Safe Drinking Water, and that is the Safe Drinking Water Act. But the Clean Water Act, that particular legislation is set up to only regulate our streams, creeks, and rivers, our bodies of water there to pull off of. And this just kind of goes through those standards with the different laws and acts that they have there. Is bottled water the answer? Bottom line, when we look at it, yes, there are some people that actually will go for their checkups, and they will go into the doctor's office, and they will ask you to make sure either one, throw away the bottle, or two, it'll lead to a discussion with your doctor. But one big thing, if we can try to recycle our bottles, some of the bottled water that's found out there, especially on that website of ours, is not as pure as the tap water, and the cost much more. And another bulleted point here, 1.4 million metric tons of plastic bottles have typically been thrown away. And fossil fuels are used to make plastic bottles. Very interesting. So we're now using fossil fuels again. It's just better if they just totally move on with bottled water. Right now, last slide, our current regulation for ocean dumping. Seems like oceans was the biggest theme here. But if we look at that with our ocean laws, or our current laws regulating the ocean dumping, the only substance that is illegal to even place or dump in a river is actually in the plastic form. Anywhere that's illegal is plastic. So basically, other stuff is fair game on there. And this just gives you what you can do to help prevent water pollution. All of these, I would specifically try to identify yourself to about 5 of them. Okay? Thank you for listening. I hope you enjoyed it.